Thanks, everyone. Welcome for joining this session. It's 2:10, so I'll just go ahead and start. Our session is about the multi-cluster GitOps application delivery, and it's about the integration between ArgoCD, Pull model, and OCM's hub and spoke pattern. So hopefully you are attracted by the ArgoCD Pull model portion, and we will go ahead and discuss them in more details. So before diving in, I do want to give a quick update about ourselves. So my name is Maggie Chen. I am from the Open Cluster Management Application Lifecycle Squad. Our OCM project focuses on a lot of components, and we are mostly working on the application deployments. So I am a full-stack software engineer. I work on both the UI portion as well as the backend portion. But today, I will be focusing mostly on the backend. And Xiangjing is our team lead, and he is a principal software engineer, and we work on the same project. If you are interested in our code base, feel free to check our GitHub pages. It's listed here. We also have our LinkedIn profile linked in the schedule, so feel free to connect us on LinkedIn. So you may wonder, what is OCM? OCM stands for Open Cluster Management. It is a CNCF Sandbox project, so community approved, hopefully. And it is multi-cluster, multi-cloud Kubernetes cluster management, so that you can deploy application policies and stuff to your managed cluster in a scalable environment. So we are using the hub and spoke architecture, which I'm going to show you the diagram shortly. Lastly, with OCM, you will be able to get a centralized view of your entire fleet. So on this diagram, and this is our hub and spoke pattern. You can see on the hub cluster, we have the placement resources that's going to deploy placement decision. So placement decision is going to bind cluster sets. So that way you are able to select a set of clusters to deploy your application or policies to. Placement itself has predicate so that you can perform label selector or claim selector. And in the prioritize, you can see how many of clusters are actually selected. So on the top right, we have a YAML template that shows the placement decision. You can see I'm using the cluster set called global. With OCM, you will get a default global cluster set that's going to select all managed clusters that you got. So you can narrow that down to just using a label selection. So saying, I only care about cloud on Amazon. So you can do cloud in Amazon or any other provider connections. Another resource that I briefly covered is the managed cluster. So you can perform OC get managed cluster or kubectl get managed cluster, whether you are using OpenShift or not. So that way you can get a list of managed clusters that are specified to certain cloud providers. So as of today, Argo CD mostly just use push model, which is quite simple. On your hub cluster, you get your Argo CD operator, and it's going to create an application set that generates a set of applications. So Argo CD's application controller will then connect to the remote cluster and deploy the resources from the application to the remote clusters. So it's just like one way from the hub to the managed clusters. What we are proposing, and which is currently merged by the Argo CD community, is the Pull model. So you can see that aside from the Argo CD icon, we now have the OCM icon, which is the purple-ish cloud thing. So we now interact in between the Argo CD hub and managed clusters. So same thing on the hub cluster, you still have the Argo CD operator, and it's going to generate the applications. But instead of connecting to the managed cluster and deploy resources directly, our OCM propagation controller actually see those applications, and they're going to create manifest work objects, wrapping the application objects as payload. And our agent on the managed cluster is going to see them and pull the application from the hub to the managed cluster. So as you recall in the previous slide, there's no applications on the managed cluster. But now we have each application on each managed cluster. One prerequisite for that is you need to install the Argo CD controller on the managed clusters. There are a few different ways to do that. First, you can use OCM's policy template to generate that to each managed cluster. Or you can use what Dan Garfield just demoed this morning. Thanks for coming, that you can use Argos of Argos to install those operators on each managed clusters. So there are different approaches that you can perform. And then Argo CD controller will see those applications and perform local cluster deployment. So why do we want to do this? It does provide a few advantages. The first one is that it's going to scale better. We do have some skill tests that Xiangjing is going to cover shortly. And we also increase the security by no longer requiring the credential to be stored in a centralized location, which is a hub. Lastly, it's reducing the impact of a single point of centralized failure. So if your hub failed, you still have the application on your managed cluster, and they can still perform local deployment. Now I'm going to pass over to Xiangjing for more details.
Okay, so here we can see this is the whole Argo CD Pull model architecture. That looks very complicated. There are a lot of workflows, but let me try to break down into three major parts. The first one is located here. So we call it propagation. And actually, we have the local propagation and the remote propagation. I will talk about it in detail later in next slides. But before that, I just want to highlight the purpose of this propagation is to deploy the Argo CD applications to the managed classes. So we're not deploying the resources to the remote classes. We just deployed the Argo CD application templates to every managed classes that our placement decisions already selected. And this is the first major components located here. And the second part is the local deployment. So once the Argo CD application is deployed on each of the managed clusters here, and then the native Argo CD application controller will be reconciled. It will be pull resources from the Git repo and Helm repo, and it will also deploy the resources, but just for this given managed cluster. So they're not talking to all the other managed cluster. So as Maggie just mentioned, so one managed cluster, we have just one Argo CD instance running on that managed cluster. And see here, the last major components that's showed here. So that's all of these components they are just for one goal. So after we deploy all the Argo CD applications to all managed clusters, and then we need to find a way to fetch the Argo CD application status from all the managed clusters. And then we collect it into the database, and then we have some aggregation controller finally to aggregate all the status, including the overall status and the per cluster condition status, and then we combine them into one final resource. That's the new CRD we introduced in the Pull model. We call it a multi-cluster application set report. So here, so that's also located in the original Argo CD application set that the user created. Okay, so let's talk about some details in each of the major workflow. So the first one is the two propagations. So here is so the user firstly they create an Argo CD application set in a hub namespace, and then at this point the Argo CD application set controller will be reconciled to do this local propagation. So this is the total functionality provided by the Argo CD. So we're not owning it. So after this propagation, then we can see, let's see if the clusters numbers is 1,000, then this native Argo CD application set controller will be creating a 1,000 Argo CD application templates into the same namespace. And then here, the second propagation is owned by us. We introduced a new controller. We call it a propagation controller. So that will be reconciled to do the further propagation. We call it a remote propagation to propagate these Argo CD application templates from the hub to a given managed classes by using our manifest work API. So the idea is using this manifest work, then we are able to specify a cluster namespace that we want to deploy a specific workflow to this given managed cluster. So here, let me show you some details. So hopefully you can see it clearly. This is the one sample for this manifest work that's actually supported by our open cluster management community. See here, two highlights. One is the namespace. So this namespace is actually the cluster namespace. So as Maggie just introduced in the OpenShift cluster management introduction, then every managed cluster, we have a cluster namespace created on the hub. So if you want to deploy something to that managed cluster, then you have to create a manifest work here to specify the cluster namespace. And see, under the spec, we have two major sections. The first section is the manifest configs. And actually, we're defining some feedback rules here. So the purpose is, so once the Argo CD applications is deployed to the managed cluster, then we're hoping to fetch some of the status from that application status from the managed cluster. So here, by using these feedback rules, then we're able to define it using the JSON paths. See, as you can see here, so we are actually fetching two status. One is the health status, the other is the sync status. So those are the overall status reported by the Argo CD application status. This is the first section, and the second section is the workload. So that means that this is used by the manifest work. Then we will define which manifest we want this manifest work to deploy to the managed cluster. So as you can see here, this manifest, that's actually original Argo CD application templates here. So there's nothing special here. But one thing I just want to highlight here, because the pool model, we actually are leveraging the Argo CD instance running on each managed cluster to do this local deployment. So the destination here, that it has to be the local built-in server URL. That's provided by the Argo CD. So if you are familiar with Argo CD, then so you probably already see this server URL for multiple times. Okay, so once this Argo CD application is deployed to the given managed cluster, then the next step is totally owned by the native Argo CD applications. So we're not owning it. So we just deliver the Argo CD application template to the managed cluster. Then the Argo CD application controller will be reconciled to pull resources from the Git repo, Helm repo, and then do all the local deployment, but just on that managed cluster. And they have all the status reported on that managed cluster either. Okay, so the last major part is, okay, so once we have all of these applications deployed and on all the managed clusters, and the next step is that we need to find a way to collect all of these multi-cluster application status from all the managed clusters. So here we actually have three major components to support this status collection and aggregation. So the first one is, we are leveraging our OCM search component. So each search collector is running as an agent on each managed cluster that's managed by our OCM components. So it's able to collect all the Argo CD application status from each managed cluster, and then it saves all of these status to the search Postgres database running on the hub cluster and for the later query. And then the second component is the resource sync controller. So that's provided by our pool model components. So we are actually running periodically a search query for fetching the resources list and the possible error conditions from all the Argo CD application deployed on all managed clusters. And the third component we are using here is the aggregation controller. So I just want to mention that this aggregation controller and the resource sync controller, so they're all running in the same pods as the sidecar container. So the reason is, so once the resource sync controller is able to fetch the application status, and then it generates an intermediate layer of this status into a YAML format files into these shared volumes in the pod. Then these shared volumes will be picked up by the aggregation controller. So from here, see this aggregation controller is also combine two status. So it's actually fetch the overall status from the manifest work. So I just showed it. So we specify the JSON path for fetch the overall status, including the health status and the sync status. And the second one is it's also able to fetch the per cluster condition status from this intermediate YAML output. And then finally, by combining all of these informations, so we're able to generate a final multi-cluster application set report CR into the same application set namespace. So this is the how the application status collection and aggregation works here. So here I also post a YAML file here for the reference. See here, as I just mentioned, so our resource sync controller is used to fetch all the cluster conditions from all the managed classes by using the search components. Then we will generate this YAML format result into the shared volume in the pod. So one application set is actually have one YAML format output here. See here is that the first session is that we are able to get this resource list from the first application we deployed to the first managed cluster. And also we have all the cluster conditions. So we have the cluster name and we have the sync status, health status. So these sync status and health status, they're empty because we will use the manifest work to get this overall sync status and health status. So, but here we also have this conditional list. So that will be used for reporting any possible error conditions that this application could have. So if there's no error conditions, then this conditional list will be empty. Okay, so I think those are the some of the instructions for this architecture overview. Okay, so let's talk about some prerequisites to be able to use this pull model. So we actually have 4 prerequisites, but I just want to say, so those are almost all of these prerequisites, they are required by the Argo CD. So in order to use the pull model, then we have to follow the Argo CD way to set up these conditions correctly. So the first one is, so we need to install the Argo CD operator or the OpenShift GitOps operator. So they're actually the same thing. And this OpenShift GitOps operator that's running on the hub and on all the managed clusters. And it has to be installed in this fixed namespace, the OpenShift GitOps. The second prerequisite is on the hub cluster. So we have to import all the managed cluster secret to the OpenShift GitOps namespace. So that's also required by the application set controller, because if there's no cluster secret located in the Argo CD server namespace, then this managed cluster won't be identified by the application set controller. So the first local propagation will fail. So it won't be propagate the Argo CD applications to that managed cluster if it's not, there's no such cluster secret in the namespace. Okay. And the third one is this is also required by the Argo CD application controller. So right now, if we want to deploy something to the managed clusters into a specific namespace, then we have to set up this particular label to let this namespace managed by the application controller. Otherwise, so there's no RBAC control, so all the deployment will fail. Okay, then let me go back to Maggie to talk about the other prerequisite.
Yeah, so actually it's part, so I just want to say that we do have constant meetings with Argo CD community. We attend their meetings quite frequently. We propose and we have PRs and we have iterations of PRs. So it's currently in the official Argo CD documentation, and you can find the use of it, that it's specifically for open cluster management with the pull integration. So you will need to have the skip reconcile to perform the pull model on the application. So now I'm going to show you an actual, oh, sorry, I think someone was taking a picture. Sorry for injecting. Okay, so now I'm going to show you the official demo. It's also a recording because I don't want to show something surprisingly. But before I click on the play, I just want to point out that we have the terminal. Okay, I can't enlarge it. So essentially, we have the terminal for the hub and 2 managed cluster. So I'm going to perform the application set deployment on the hub cluster. So now I'm listing the managed clusters, and you can see I have demo 0, demo 1, and my local cluster. I am now applying the application set itself, and you can see the placement and application set are created successfully. Let's take a look at the application set itself. So let me scroll up and pause right here. So you can see that I am using a placement called BGDK app placement that selects the demo manage 0 and demo manage 1. I'm going to show you the placement shortly. But I do want to point out under the metadata annotations, there are some OCM-specific labels, so such as the OCM managed cluster that's going to inject the managed cluster name, OCM managed cluster app namespace, which was the one we defined, as well as the script reconcile, and you can find more documentation on it on the official Argo doc. So now if I, aside from that, you can see the other spec, like destination project source are just what you would usually create application set. We didn't do much variations on this spec. And let's take a look at the placement. So for this placement, I didn't use AWS. I'm using environment to demo. And you can see I'm using the global cluster set, and I have 2 clusters selected. And it's also reflected under the status. In terms of the placement decision, you can see I do have a list of decisions, which shows my 2 cluster names. Now, let's take a look at the application, and you can see they are deployed on the hub, but our actual managed cluster deployment are not from the hub. We are going to have an application on each managed cluster itself, and you can see that they are created by OCM's propagation operator. So resources are also deployed. You can see the replica set deployment, everything was in a healthy state, and including route as well. So let's take a look at the application YAML itself. It's the same Argo application template. It has a list of resources and what the status of those are. They're all healthy, which is great. And on the hub cluster, let's verify those status by OCM's multi-cluster application set report. So this is a resource that's created by OCM. And you can see that we do have a list of resources. And under the cluster status, they're all healthy. Resources are listed here, and we have this overall status by saying we have 2 clusters selected, and both of them are healthy, and they're all synced. So that's the success route. I mean, in general, you would have progressing stuck or actually failed status. So I do want to show you that. So now I am deploying an application set that's going to get stuck. So you can see it's actually in a sync state and progressing on the managed cluster. So taking a look at the application on the managed cluster, it should going to reflect what you just saw. So even though some of the resources are synced, you can see we have certain resources that stuck in a progressing state, and we do have the messages. They are waiting for some rollouts, and they will never end because we intentionally made them to wait for something. So we do want to make sure the multi-cluster application set report also get reflected. And as you can see under the summary, we now have 2 clusters. None of them are healthy, and they are always in progress. So if you scroll up, you still have a list of resources listed, but the health status are now stuck in progressing. They're still in sync, so that's a good portion. Oh, by the way, all of the applications are using the same placement, so they are both deploying to the two managed clusters. So now I am applying the third application, which is going to fail. On one of the managed cluster, I just want to verify that they failed, which is the case. It's no longer in sync. It's now missing health status, and it's out of sync. So on the application itself, you can see that if you scroll up, their health status are in missing state, and they are out of sync. I do want to point out that one limitation we have is that even though those resources failed, ideally they should still get reflected on our hub, which is the multi-cluster application set report, but that's not the case. So if you look at the resource list, we only have a service client, which is not true because you can see that we have deployment that failed. So that's one of our limitations/bug that we should enhance. So I just want to point that out. But aside from that, we have not healthy and not sync status, which is true. So under the condition, we also have those failed messages reflected from the managed cluster to the hub cluster. That's pretty much it for my demo portion. So let me go ahead and discuss the limitations. So I already covered the number 2, which is that we should have all of the resources from the managed cluster to the hub, which didn't happen nowadays for the fail state. Another limitation we have is that resources are only deployed on the managed clusters. So with the pool model, they're not deployed on the hub cluster. And lastly, in the pool model, we are excluding the local cluster as a target managed cluster. So there are a lot of different ways to reach us if you're interested in the pool model or want to enhance the pool model. So we have the GitHub page, we have website and docs. If you want to interact and reach us, we have Slack channel, YouTube channel, mailing group, and community meetings. You can also reach us on LinkedIn if you're interested as well. Johnny, do you want to tell about the skill test?
Yeah. I just want to mention there is, so as Maggie just mentioned, so there are some limitations that we already identified. And that's partially because the limitations for our search component and our manifest work limitations. Firstly, so right now our manifest work is the feedback rules, as I just demoed. So it's only supported to fetching the string data type. So it's not supported to fetch the list data type. So that's why we have to rely on the search components to collect those list resources and the list of the error conditions. But the search components, so one of the major things is that it has to be find all the resources that actually are deployed on the managed clusters, which means that it has have the UID. Otherwise, those field resources won't be fetched by the search collector. So with these 2 limitations that we identified, and we actually have a roadmap plan that's under the consideration. So I just want to share it here for you guys. So our manifest work, we already have a proposal to enhance our manifest work API. So by that way, then the manifest work will be able to fetch the list data as a raw JSON. So with that way, then we just need to fetch all the overall status and the per cluster condition status from the managed clusters by fetching the status from the manifest work status directly. Then if that is ready, then we probably will drop all of these search components dependency in the future releases. So that will provide us more efficiency. The other one is I just want to spend maybe 30 minutes to talk about some of the performance tests. So that's still on the way, so we're not finished, but we just want to prove that this advantage of the scalability by using this Pull model. So actually, we run this case, we actually deployed 20, before that, so I just want to share two numbers that our, thanks to our GitOps, OpenShift GitOps operator team. So they actually talk about two numbers that right now the native Argo CD they have. The first one is the total numbers of the application that they can control. So they found that once the numbers of applications are using the push model is over 1,000, the whole Argo CD application UI will have some performance issue, so they're not stable. And the second number is, they found that once one Argo CD instance, they are deploying resources to over 100 clusters, so they also hit some performance issue. So here we already run some performance tests using this Pull model, and our scenario is we deployed 20 application sets to 500 managed clusters. So the total numbers of applications would be the 10,000 applications in total. So within 2.5 minutes, then we get all the managed clusters reported in our final multi-cluster application set report. So those are the rough performance status I want to share here. Okay, so that's.
Thanks.
Any other questions?
Hi.
Can you, yep. I saw in the demo for the application set deployment that you had an annotation for targeting a managed cluster. If you don't use that annotation, are you basically saying, I want it to just go to all managed clusters, or is there a way to have an application set just go to all managed clusters by default?
Yeah, like if you does not specify the predicates, it's just going to use a cluster set, which is the global cluster set that's going to deploy to all clusters. So it's just like if you want to select a set of the cluster, that will be a way, but you can definitely have the choice to deploy to all clusters.
Right, so maybe to be more specific, sorry.
Yeah, we can be close. Yeah, essentially you can delete everything under the spec, to be honest. And you can also delete everything under the predicates. It's just an option for you to narrow down the list.
Thank you.
No problem.
So on a scale of 1 to 10, where 1 is your pre-alpha and 10 this is in production and it's bulletproof, where would you put OCM? Or another question is, do you have customers that are using it today in production?
I think do we have any like in real customer? I think it's still under development, and that's why we want to be here to raise some awareness. So we are going to develop more in next release, but this is, I would say, an alpha state. Yeah. And you can see we have a lot of prerequisites, which is not ideal. And I am looking forward to collaborate with Argo more, so that maybe we can reduce the number of prerequisites to maybe just one.
Okay, thank you.
Right, and so for this Pull model feature, so we are planning to release it in our downstream project called ACM. That will be released in this June. So in 2.8. So that will be published along with that release in June.
Is there any question? If not, I think thanks everyone for joining. We are looking forward to see more contributions in the future. And thanks, Argo.
Thank you.
Thank you.